Hello everyone. I hope you are enjoying these online sessions of this teaching and learning process. So yesterday we have started a topic controls using programmable logic controllers. So the PLC is heart of this chapter. So yesterday we have covered following bits. In this we have seen what is the controller and why it is important. Again we have covered the programming logic control, that is what PLC, how the input outputs and the program help to PLC to perform an action or to perform or to carry some output. Then we have seen Allen Bradley PLCs, Siemens PLCs, and its some amount of prices. Again after we have seen important point, that is what PLC architecture. That diagram is very important, which contains RAM, ROM, address bus, different address buses, and all that we have seen yesterday. Also we have seen the ladder diagrams, how we are preparing the ladder diagrams, how that ladder diagram helps the PLC programming, and how that PLC programming helps microprocessor to convert that program into the machine code, that we have seen yesterday. Also we have seen one example of ladder diagram yesterday, how that input output works in the PLC, what is that power rails or power lines, how the switches are working in the ladder diagram, and all that. So today we are going to see the sequence followed by the PLC as follows. Actually this slide we have seen in the extra lecture. As a point of a reminder, I would like to explain this slide once again, so you will remember the concept of ladder diagram. So first thing is what the scan. First step is what? Scan the input associated with one rung of the ladder diagram. As already told you, we have to scan every rung from the ladder diagram. Then solve the logic operations involving into this. Then set the output of that rung, move on the next rung, and repeat operation 1 2 3. So this process goes on up to the last rung, up till you will not find out the end in the program. So that was the sequence followed by the PLC we have seen yesterday. Now next we are going to see that is the starting of this today's session. The conventions need to be followed in the PLC when preparing a ladder diagrams. So some rules or some conventions we supposed to follow when we are preparing a ladder diagrams for a specific problem. So in this first is what? The vertical lines of diagram represent the power rails in which circuits are connected. So yesterday we have seen there are two vertical lines, left power rail and right power rail. So in between there used to be rungs one by one. So two lines are there, that these will be the power lines, and in between we have to show the circuit. So that circuit, or we can say each rung on the ladder defines one operation in the control process. Every rung will carry one operation. Then third point is a ladder diagram is read from left to right and from top to bottom. So this is again very important as far as direction is concerned in the ladder diagram. It is starting from left to right and from top to bottom. Electric devices are shown in their normal condition. Now this is very important. If in the problem if it is mentioned that one of the switch is open, then in the ladder diagram you have to show that switch normally open. There should not be a contact or there should not be flow in the rung from that particular switch. So that is this point. Next point is a particular device can appear in more than one rung of ladder. One of the, suppose we will say relay, we are going to see that a relay bit ahead. So relay we can use a number of times in different rungs. There is no issue about this utilization of these electric devices. And last is the inputs and outputs are all identify their addresses. So already in the PLC architecture I mentioned that all the inputs and outputs and program stored in the memory, it is we are calling with the help of addresses. So that is this point. So this was about the conventions need to be followed in the PLC diagram when we are preparing a ladder diagram. Now next bit is very important and very interesting bit in this topic, that is what logic functions in a ladder diagram. So first of all, just try to understand what is this logic functions. As the word we are, or the topic of the topic name is PLC, programmable logic controls. So logic word is very important. So how this logic plays to give some output, because PLC is working again what input conditions we are giving and what output we supposed to get out of that. So depending upon that input and output parameter, we supposed to write a program. So this writing a program is very important. In this program, in this program we supposed to use some logic, because there will be definitely number of inputs and number of outputs. So just we have to make a different arrangement to follow or to get the desired output of this PLC program. So logic is very important in the PLC. So in this first type of this logic functions is AND logic function. So what it said, switch A and switch B have both to be closed, which thus gives an AND logic gate. So here you can see first diagram. Switch A is there, switch B is there. They are in normally open condition because there is no any further flow in the system. But if these switches will close, then and then only we are going to get some output at this end. It means what is important in the AND logic gate, switch A and switch B should be closed, normally closed, then we can get the output at this end. So in the ladder diagram, this is the ladder diagram of this AND gate. This is the input A, this is input B. Currently they are in normally open condition. So what is the condition says by the AND logic function? We have to close this switch A, this switch B, then we will get some output in the run, in that particular run. So this is what a truth table for this AND logic gate. You can see input A is 0, input B is 0. So it means switch A is open, switch B is open, so output will not get from this run. Another case you can say, in this switch B is in closed condition, then also you can't get the output. Third stage, input A is on, so again you can't get the output. But in final stage, input A and input B is in on condition, that is what it is in closed condition, so you will get the output over here. So this is nothing but the truth table for this AND logic gate. The example of this AND logic gate or AND logic function is what? Bulgar alarm. So person sensor will detect the movement of thief, that is the input A, and alarm switch operate on that basis, that will be input B. So here input A and input B, if it is activated, then and then only we will get the output at this end. So this is the example of AND logic gate. So I hope you understood this. Next type of the logic function is OR logic function, or another name is OR logic gate. So what is the condition for this OR logic function? Switch A or switch B have both to be closed, which thus gives an OR logic gate. So the meaning of this is what? One switch must be closed. One switch must be closed. You can see here in the electric circuit diagram, either you can close this switch A to operate output, or either you can close this switch B to get a output. So in the truth table you can find out if there is at least one input having one signal, then you can get the one output. 1 is what in on condition, 0 is what in off condition. So here A is on, you can get the output, B is on, you can get the output, and last is what? If both the inputs are on, then also you can get the output from that table or in the OR logic. Its example is, you can see here, this is the ladder diagram. These are the different arrangements of the ladder diagrams for this OR logic gate. You can attach this input B to the parallel to the input A in this fashion, or you can directly connect input B to this power rail, and it must be again in parallel with input A. So it is important that at least one input must be in or on condition, or it should give one out of that, so you will get the output at output channel. Example is what? Doorbell. You want to press a button at a front doorbell, you can listen the doorbell inside the house, or back, if someone press the back door switch for the doorbell, you will listen doorbell inside the home. Either one doorbell switch you need to operate, you can listen the doorbell inside the home. So this is the example of OR logic gate. Now third is what? Not logic function. Now not logic function is what? It is exactly in opposite condition. You can see the truth table. If input A is off or in 0 state, you will get the output as 1. If input A is on, you will get 0 as a output. It is exactly happening opposite or invert condition to the input. Okay, so this is the ladder diagram for this not logic gate. So here is the example of not logic gate. You can control the temperature in the room. If that, actually this example is in the in spring condition, or we can say in a winter condition, where you need to maintain some heat inside the room. So what is important in this? If the temperature is moving above the 20 degrees Celsius, this not logic gate start the central heating, and like that it works. So this is what not logic gate. Now fourth type of the logic functions is NAND logic function. Actually NAND logic function is nothing but NAND gate is the combination of AND gate and NOT gate. So here you can see the truth table. So first row you can see 0 0. It means you should get 0 at output. It means what? Input A is 0, input B is 0, you must get, or you would have been get 0 in the AND gate, but here you are getting a 1 output. So that is what? The NOT gate in the AND gate. And final line you can see, if the input A is 1, B is 1, you should get 1 as output, but you are getting as a 0. Again it is the AND gate, NOT gate in the AND gate. So these two rows work as a NAND gate, and other two lines in between, they work as a NOR gate in the NAND gate. So this is the ladder diagram for the NAND logic function. So example is what? If there are 3 fans working properly, the alarm should not rung. So that is the condition. If one of the fan is giving problem or it stops, so alarm should on. Instead of 1, 2 fans, if they are not working, alarm should get on. Like that it is working. So that is the example of NAND logic application, NAND logic. Next is NOR logic function. So NOR, again it is the combination of OR gate and NOT gate. So you can focus on this truth table. In a NOR gate, in OR gate, what is important? At least one input should be 1, then and then only you will get output as a 1. So in a OR gate, this 0 might be, or it would have been 0, but here it is getting 1. Again in another line, in OR gate, this 1 input should be reflected in output as a 1, but it is indicating 0. So if we talk about this truth table, or if we compare this truth table with OR gate, it is exactly inverse of this OR gate. So that is what the NOR gate. NOR is what? OR plus AND gate. Sorry, OR plus NOT gate. So this is what a ladder diagram for this NOR function. Now this is what one kind of application, or we can say it is using for complex cases. So for complex applications, such kind of NOR logic functions are working. So this is what just a diagram of that you can see in this. Next is exclusive OR, or another name is XOR logic function. The OR gate gives an output when either or both of the inputs are on. So what it says, just to remember OR gate. In the OR gate, what is important? At least input A or input B should be on, then you will get the output 1. So in the first 3 lines it is following, but last gate, last row in OR gate, what was the answer? Input A is on, input B is on, then you would have been got output 1. But this XOR is properly or exactly working for this last row. Even both the inputs are on, you should not get output as on or active. So that is the, for this row, this exclusive OR works. Again, its application is in complex cases or miscellaneous cases, and it requires for manufacturing or creating this logic, XOR logic, you need to have 2 NOT gates, 2 AND gates, and 1 OR gate. So like this it will follow this final row condition. This is the ladder diagram for this exclusive OR function. Now these are just a summary chart of these logic functions or logic gates. So you can see, first we have seen AND gate. This is the symbol we have to use in the ladder diagram for the AND gate. This is the notation, A into B. Whatever this truth table we are going to get, it is the combination of input A and input B. If input A is 0 and input B is suppose 1, so you will get the 0. When you are going to get output 1, if input A is on, input B is on, that is what input A is 1, input B is 1, and you will get the input 1 into 1, you will get output as a 1. So like this, these notations work, and this you can implement for a remaining other gates. Another gate we have seen, OR gate. This is the symbol, this is the notation, A plus B. This is the truth table for this OR gate. This is a NOT gate. This is what a NOT gate. So it is exactly works in invert condition. Input is 0, gate will give the input 1, or we can say input is off, you will get the input as a on. So this symbol in the gate indicates the NOT gate. Again, another we have seen NAND gate. In that it is exactly inverse of AND gate. This is AND gate, and its inverse is what? NAND gate. This is the truth table. Another is NOR gate. Again, it is inverse of OR gate. This is the truth table. And finally is what? XOR gate. This is the symbol for XOR gate, and again this is the truth table for the XOR gate. So this is what today's session is supposed to conclude here with these logic gates. I hope you enjoyed this logic functions. We will meet with the next concept or new concept in the tomorrow's video lecture. Thank you very much.